here was the question about memory. There's important information in memory. There are some common tools for dealing with that, for actually capturing memory. Most of these are on Windows machines. You can actually capture memory on a Mac, capture memory on a Unix box as well. So now you've captured a bunch of memory, and you need to do something with it. There's a couple opportunities to deal with it. One is a set of scripts called the volatility framework, which are public domain scripts that you can actually plow through that memory and actually determine stuff through it. There's also memory and capture and memory analysis that's built into FTK, where FTK is a forensic toolkit. It's a commercial product from Access Data. You can actually do memory analysis in that kit. All because of the volatile memory. You can look through and do strings, tell me what's in this memory. There might be some goodies I'm concerned with. Okay, so essentially, I've spoken of this concept in other courses. There's this notion of an arms race. Anybody can copy a disk, and so I'm winning the race. Now let's add encryption. So now the intruders are winning. Well, I can deal with encryption because the passphrase for the encrypted drive is in memory. Now it's not in memory anymore because it's been overwritten. It's only available for a very brief period of time. So you get the idea of the arms race. I do something, the intruders do something else, and on and on and on. So the latest is being able to capture memory and to do something with it. Now, the volatility framework and FTK, all of these tools, look at memory and try to figure out what's in that memory, try to rebuild data structures and such. That can be challenging when you don't have the source code for the system that you're trying to reverse engineer, and so you're trying to guess, intelligent guess, how the data structures in the kernel are laid out. So the volatility framework has been a bit of an example of saying, oh, I think this is how Windows XP, and it only applies to XP, SP2, and 3, how XP lays out memory. Because I don't have the source code from the vendor to say, oh, I see how it lays out memory. I can then plow through those data structures correctly. So there's a little bit of, it makes sense, it looks good, I'm not exactly sure. Now, the other place where the volatility framework and those kinds of tools can be beneficial is in rootkits. Anybody know what a rootkit is? What is one of the functions of a rootkit? Hiding itself, among other things. So if you go to a task manager under Windows and say, tell me everything that's running, somebody's snickering in the background saying, I've only told you the things I want you to see, not the things I don't want you to see. But if I capture that memory, take it over to my analysis platform and analyze it with volatility or with FTK, I will see everything that's in there, not something through the rose-colored glasses of the rootkit. So you want to do some analysis on that machine, but you also want to do some post-analysis of memory, and that can give you some clues as to what's going on. So that's a counter-forensic tip. Memory is important, and now you're back into it's volatile and it's important, go capture it first. So now, and again, this slide is born of the fact that we learned something as part of the activity. You've now spent all of this time imaging. You've got your plans, you've got your write blockers, you've got your donuts, you've got your coffee, you've imaged everything, and now you're ready to leave. Did anybody look at the images and see if they were usable before you left? You may not get a second crack. And so, can I read it? Is it there? Can I understand it? And can I do further analysis? Because if I haven't captured it, chances are good I'm not going to get a chance to go back. Once you leave, you may not get that chance. Yes?
Do you have a standard, not that I would want you to tell me what it was, but do you have a standard way that you label everything so that, and do you use that kind of template for each case?
That's the right way to do it. That's the best practice. It needs to be labeled in such a way that you can figure out what it is. As we are evolving within our own organization, we are coming up with those standard templates. Law enforcement organizations who do this day after day have that, so that they can tie it together with their evidence handling custodian back at the ranch. And you've seen, again, somebody inside a cage, and you give the evidence and you sign logs all for the chain of custody, there's probably a paper trail or a computer database trail where there's a form of the information so that you can tie everything together. We are evolving as we get more into that, but that sort of thing should exist.